All right, turn to page 6 in your packet because now we're getting into reviewing some multi-step equations and tackling my favorite thing in the world, fractions. So here we go. All right, look at example number 1. Now, in the past when we've looked at all of equation stuff, we figure out where is the equal sign, and then your big challenge is get the variable all by itself on one side of the equation. So oftentimes we have to do some simplifying. We might have to combine some like terms. We might have to use the distributive property. We might want to do clearing the fractions, and I'll explain that in a minute. So you basically want to get your variable, if it's x or y or z, you want one x on one side of the equation and everything else on the other side so you can solve it. So let's take a look at this first one. I have 1, 2, 3, 4 terms on the left side, 37 on the right. Okay, one term on the right. Basically what we want to do here is combine like terms. So I already put dots up here. I have an 8x and a plus 3x. That gives me a total of 11 x's. Constant-wise, I have a positive 6 and I'm subtracting 2. Now, if it helps you to just come up off to the side where you have some room and go ahead and say, all right, I'm going to use the commutative property to change my order. This is a plus 3x. And say, all right, those two give me the 11x. These two give me the 4. Cool. Now, this is where I say, all right, at this point, put a line under the equal sign because that tells me, hey, this is balanced and I cannot do something to one side without doing the same thing to the other side to keep it balanced. It's kind of like you, let's say you have an annoying older sister and one person or she got something and I didn't. Of course, I was going to yell, hey, that's not fair. Same thing here. When you see where you're going to put that balance bar, is what I should call it, whatever you do to one side, make sure you do it to the other. What we're doing next is we're subtracting 4. The reason we're doing that is because this is a plus 4, and 4 minus 4 goes to 0. Woo! That means I'm just left with 11x. But we subtract to undo the addition. That's why we do that. So they're called inverse operations. 37 minus 4 is 33. Now I have 11 times x. That's what's really going on there. And now we have to undo the multiplication. And we're going to divide because those two are the inverse operations of each other. 11 divided by 11 is 1. X is 3. Now, really what we should do is check our answer. You could just use a calculator to do this part, but you should really check. 8 times 3 is 24. Okay? And then we're going to add 6. Then I have to take 3 times 3, which is 9. And then I'm going to subtract 2. This is taking a look at that left side of the equation. All right, now I can just go left to right. That's 30. And I'm going to add 9 more. That's 39. Subtract 2. 37. Woo! Score! It works. Okay, let's look at example 2. You do not have the right to flip out just because you see fractions, okay? Now, this gets a little cumbersome with how they've written it here, but just follow along with me. I have this term over 4 plus this term over 4 equals negative 3 over 4. If they all have the same exact denominator, I call it kind of like this game show. We're going to use the distributive property. In fact, you can write that right here. And the best part about this is if you have all the same denominator, we can take that denominator, multiply both sides by that denominator. In this case, it's 4. And poof, it clears the denominator out of there. It clears the fractions because 4 times 5n over 4, that's what they've written right here. This is like 4 over 1 and a 4 in the numerator. divides the 4 in the denominator, and now I just have 5n. Distributing the 4 to 7/4, like they've written right here, this 4 divides the denominator into both being 1s, and you just have 7. 4 times -3/4 is just -3. You see what we did? It's just like swoosh, cleared them all out of there. This is way easier to solve now. Now it really looks like this. 5n plus 7 equals -3. I think it looks a little more difficult in the boxes, but if I look at it this way, I'm like, hey, I'm going to subtract, and I'm going to subtract 7 to undo the adding of 7. And yay, hooray, that goes away because 7 and -7 is 0. I have 5n. All right, hey, how are you with your integers? -3 minus 7 more, that's -10. And now when I divide both sides by 5, because I have to divide to undo multiplication, oh my stars, I get -2. Now, in theory, we should go check all that. If I put, there's only one spot to check it up here. 5 times n, 5 times -2, divided by 4. Okay, hold your horses. Let's do that right now. -10 over 4. Okay, now I'm just going to leave it like this because everything has fourths in it. Plus 7/4. -10/4 plus 7/4 would give me -3/4. That's exactly what we got. Yeah, the crowd goes wild. All right, the next page in your packet, I like the problem, but it gets very cumbersome with all those boxes. So I just want to dive in and start doing a few of these with you. The problem is this worksheet is great, but it has no room for you to work. So get a separate piece of paper, and we're going to show our work on a separate piece of paper. Okay? Let's look at, well, let's start at the very beginning. It's a very good place to start. 2x plus 5x plus 4. I can combine terms right away because 2x and 5x gives me 7x. Plus the constant 4 equals 25. Put your bar right under that equal sign. Start undoing to get that variable isolated. I'm going to get rid of 4 first. That goes to 0. Yippee skippy. 7x equals 21. Whoa! I am going to get, after I divide by 7. Now, you want to write a 1x? Go ahead. I kind of like just writing x, but I like to also emphasize that 7 divided by 7 is 1. I get +3. Does that work? In your head, you could do this. 2 times 3 is 6. 5 times 3 is 15. 6 plus 15, 21, plus 4 more, 25. Whew. You could celebrate every single time. X equals 3. Make sure that you please don't just write 3 on the line, write x equals 3 because we're solving for the variable each time. All right, let's do one more together. And I want to do number 7 because it has fractions. What? You're going to need another piece of paper because with all the fractions, it's just kind of something. Let's copy it down. And you know what? I write really big. I'll just make it fit here. 5m over 8 minus 6 over 8 plus 3m over 8 equals 2 over 8. Hot diggity dog. Everything has eighths. So here's what we're going to do. I'm going to put jumbo brackets around that entire expression and on this one. We are going to multiply because it's perfectly legal to multiply both sides of the equation as long as you are fair. Do the same number. And I'm going to multiply both sides by 8 because here's what's going to happen. On this side, when I distribute that to every term, it wipes out the fraction. It clears the denominator. Whoosh! I just have 5m. This times the middle term, 8 times -6/8. There you go. this minus plus 3m over 8? Yes. And 2/8 times 8 is just going to be 2. Don't believe me? 2 times 8 is 16. 16 over 8 is 2. Boom! Now, we've got to do a little combining of like terms before I draw my bar and start undoing or using inverse operations. 5m and 3m, because they're on the same side of my equation, let's clean that up. That combines to 8m. Now we can go to town. Add 6 to each side. 8m equals 8. Divide by 8. 8 is really great. 1m equals 1. Oh my word. M equals 1. Check it in your head. I can't do that. Yes, you can. 5 times 1 is 5. 5/8 minus 6/8. That's a negative 1/8. Plus 3 times 1 plus 3/8. That's, okay, hold on. Negative 1 plus 3 is 2. Yes, that works. There you go. All right. Look for your assignment on Schoology. Show your work. Be patient. And of course, may the force be with you.